Okay, so this is the last slide that we have seen, and I'm just going to, because I forgot to press the record button. This is the last slide that we seen last time we saw each other, and we were talking about getting on and off the scaffold, because this is not a video game. We can't just teleport ourselves on and off that thing. Maybe someday, but before we do that, we're going to use some ladders. And I said that again, but if you're watching the recording, you're going to have the illusion that I said it for the first time. There you go. All right. So when it comes to using ladders, the rules apply just as if we were talking about the ladders in our previous lecture. And there's one more little detail to add, because scaffold sometimes is a freestanding structure, and they have different shapes and forms and different center of gravity, different size of the bases and different heights. Well, there's a lot to consider. All the rules of using ladders apply that we talked about. Plus, you got to make sure that you don't tip the whole thing by putting a ladder against and putting yourself on top of the ladder. Okay, so what is it that we have to know here? Ladders, portable access ladder must be secured to prevent displacement. Okay, well, secure from the top, secure from the bottom. We have learned that already. Must extend at least 3 feet above the landing surface to provide a handhold. Well, same thing as we talked about before, right? You need to have 3 feet above the landing surface. Where is the landing surface? Well, here's your starting point. You're going to climb the ladder, climb, 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 and you're going to land on that surface. So this is your landing surface, and the ladder has to be extended 3 feet above the landing surface. Now, is this landing surface the platform, or is it the landing surface that the railing is? And while in some cases it's going to be this, in some cases it's going to be that, depending on how you're stepping on things and how you're accessing that. Just to be on the safe side, I would extend that 3 feet above the railing, so nobody can hold anything against you. All right. Now, attachable ladders. Also, there's how can we get on and off the scaffolds? Well, we could use attachable ladders. And these are permitted as well. So instead of having an extension ladder or a straight ladder or whatnot to get on and off, or you can get actually through the window as well, you could have an attachable ladder, and they are designed, just have to use the ones that are designed to do the job properly. You can't rig anything, or so-called, I don't know, jerry rig or something like it's an old expression. So there. Now, when I'm talking about the scaffolds here, usually when it comes to big projects like this, that you can see on the picture, usually you will have a company set it up for you, right? Things have changed a little bit over the years. However, well, it's, the company I'm talking about, the rental company, with people who are competent in setting this up, right? However, I'm giving you the awareness for a couple reasons here. One is when the company comes and sets things up, what if something goes wrong? You should be able to spot that, pinpoint that, and correct that, or maybe make a phone call for someone to come and correct the problem. So that's one big thing, because this is not a commercial, it's not a consumer product, it's a commercial product. So the difference is that when you are buying something in the store, like a department store or a hardware store, things that are sold and they're on the shelves, some of them use electricity, some of them use other things like hydraulics or whatnot. But for the most part, unless it's not. For the most part, things are designed and produced and put together in a way that the person doesn't have to know anything about electricity to be able to use that. So it's a consumer type of putting things together, consumer type of manufacturing, a consumer product arrangement. Right? You don't have to be an electrician to use the iron to iron your shirt. Right? You don't have to be a plumber to be able to take a shower, right? And things like that. But when it comes to construction sites, things are rough. The environment is rough. Things are being in construction during construction. So um, you have to have some sort of knowledge when it comes to safety and well, pretty much safety of things, right? And the proper usage of whatever you're using. And mainly, what I'm talking about here is raising awareness towards not hurting yourselves, right? And sometimes the other reason is why I'm talking to you about this, and we have that as part of the curriculum, is yes, sometimes you're going to be required to put some sort of small scaffold structure yourself when it comes to doing construction work. Excuse me. Sorry about that. And also, the third reason that I'm going to mention is that how to use it. Like, for example, we're not supposed to put a step ladder on top of the platforms. Okay. So you can set it up, this thing can be set up properly all you want, but if you are using things the wrong way, you're also, well, putting yourself in danger, and you're responsible for, could be held responsible for accidents to happen to yourself and to other people. Now, also what I'm going to mention, that if you are working on heights, and I'm not talking about, some of the 1920s, 1930s pictures when they were doing the construction in New York or whatever that was, the bridges and big buildings. No, that's not what I'm talking about. Heights, 6 foot step ladder. That's working on heights. You're raising yourself up. You're on some sort of height, and if in order for you to be able to use even a 6 foot step ladder, it used to be different. You could just use a 6 foot step ladder and carry it on, and use it properly. You didn't have to have a ticket for that. Now you do. Right? So even if you're using a 6 foot step ladder, you should have a ticket that says working on heights. Now, when you're using some mechanical devices like a boom lift or a scissor lift, then you need additional ticket. Right? It's called a lift ticket. And well, they change sometimes. Last time I checked, it was working on heights. It used to be called fall arrest, and fall arrest means it's not like there's a fall. I'm going to put that fall under arrest. It's basically a fall prevention. Right? So that's what it is. So you need to have the working on heights. Now, it used to be called fall arrest ticket. Now it's working on the heights ticket. Well, same thing, different name, but basically it is prevention of falling. Right? Unless you are into martial arts like wrestling or judo or something, then you're going to learn how to fall. But we're not talking about that. Right? So where do you get those tickets? The good place to start asking where to get them is rental companies who rent the lift equipment, rent the scissor lifts, rent the boom lifts and whatnot. They quite often have a training facility, and so they provide training. It might cost you a little bit of money, but first of all, you're not going to get killed, or you're not going to kill somebody else, or you're not going to get hurt, or you're not going to hurt somebody else. Plus, if you are on a construction site, any kind of construction site, and any kind of inspector drives by and decides to step in to check what's going on there, if they find you that you're using a ladder and you don't have the ticket, it might take a smile off your face pretty darn quickly, because the fines are nothing to be ignored. Yep. So it costs you more to not pay some of the money for the training. Plus, it's a very useful training. It can actually save your life. There is no joke. I have seen people quit their jobs because they didn't know how to use the lift equipment properly, and they got themselves into some sort of trouble, and they were lucky to come out in one piece, and nothing has happened. But I've seen a couple people just walk away from the job and never seen them again. They just want to do something else. Um, no joke. Things are serious. Gravity, um, can play a big role in your well-being. Right? All right, so scaffold. What are the other ways of getting on and off the scaffolds? When you drive around or walk around, and sometimes you're going to see the construction site behind the fence or whatnot, pay attention on to those some of those details that I'm talking to you about right now. Um, Scaffold stairway. That's another way of getting on and off the scaffold. That's probably the most comfortable way and the safest way, I would say, to get on and off. Uh, I bet you didn't see some of that stuff, but now when you drive by or walk by, you're gonna see some construction site, you're gonna see some of the scaffolds put together. You're going to notice things like that right now. All right. Falling objects. Well, scaffolds are platforms, raised platforms, and people are walking on them. People using their tools on them. So objects are being, there are people and there are objects. So we need to, well, we need to make sure that people don't fall off the scaffolds, but also we need to make sure that the objects are not falling from the scaffolds, because first it can cost you money. Second, it can hurt somebody if it falls on somebody's head or any part of their body, as a matter of fact. All right, so anyone working on or the scaffold must wear a hard hat. Anyone working on or around a scaffold, well, it's a given. If you're on a construction site, you need to have a hard hat. However, sometimes people step away from certain things, and there are certain areas that you don't need to have a hard hat. But for the most part, once you're there, you should have it. Uh, Especially if you're on or around. Okay, to prevent you from being hit. As far as I remember, the hard hat idea. Well, in North America, at least, was pretty much invented. The idea was thought of while building the Hoover Dam, in the States. Objects were falling onto people's heads, and people said, "Hey, you know what? I'm gonna wear something hard on my head, so if something hits me, I'm not going to get, splitting headache, literally." Right? So hard hats prevent. Okay, I'm not going to talk about that because it's self-explanatory. All right. Before I get too poetic about this, workers on or below scaffold must be protected from falling objects. Right. So workers on or especially from below the scaffolds must be protected from falling objects by what means? By toe boards, and we're going to take a look at them, mesh, screens, or equivalent measures. So that pretty much covers whatever else is invented and approved to prevent objects from falling down from up. Get it? Okay. All right. That's the wrong way here. All right. So what about toe boards? This is a toe board. Yeah, see that? There are different shapes and forms, but this is the simplest way of a toe board. Just like the toes on your feet. Right? Um, Board. So you would touch the toe board with your toad with your toes. All right, and that would prevent objects from falling. Nothing is 100% guaranteed, but we take the measures that we can with what we have, and some things are approved and some things are not. Toe boards are good, right? No toe boards are not good. Why am I not changing the slide? Okay, so here is here's an example of a screen or a mesh, right? Again, you get some extra protection from objects falling down from where you are working. And because I inherited this presentation from the previous years, way before, this slide shows what type of scaffold do you use. All right. What can you tell about this scaffold? Well, it got some platforms. Are they wide enough? I don't think so. Do they reach at least 6 inches from the support? Yes, they do. All right. Do they have cleats? I don't know if they do. Um, People are not wearing harnesses. They're wearing hard hats. Um, yeah. How to get on and off? Is there 2 feet down and up from the landing surface? I don't think so. So you know what? This is an example of things being done. Well, I don't want to use the strong word wrong, but it comes to my mind. But it's not a very safe thing to do. And sometimes, excuse me, you're going to see people do that. All right. The types of scaffolds that we have covered or we're covering here. We're talking about fabricated frame scaffold, pump jack scaffold, ladder jack scaffold, trestle and horse scaffold, mobile scaffold. I feel like Forrest Gump with Baba telling him to how many kinds of shrimp soup, or we can make shrimp or whatever. So roof bracket scaffold, top plate scaffold, area lift scaffold, um, work platforms attached to the forklifts. Those are also work platforms. Yeah, you're going to see some of that. We're just going to touch on some of them, right? And that's pretty much all that we can mention here. Now, just to show some of the idea of what this would be the trestle and horse type of a scaffold. Right? Now, this here, it's a ladder jack. You put the supports on the ladders, you fasten the ladders, and then you walk on the platform. It's called ladder jack. Where is it? Come on. Okay, here is similar thing to a ladder jack, but it's called a pump jack. You see this guy has a foot on some sort of a device here. It's a foot pump, foot lever. You pump it up. You adjust the direction of it, and you pump things up to go up, or you pump things to go down. A pump jack. Right? Of course, when it comes to fall arrest, you need harnesses. And it seems like this guy is nicely strapped, so he's safe. Is this guy safe? I don't think so. Consider some things, and you're going to get whenever you're going to decide to work on some heights, and when it comes to installing wires, doing electrical work or data work, you're going to have to put yourself higher than the ground and higher than you can reach, mostly on the inside of the buildings, but sometimes you're going to have to mount things on the outside as well. And I'll tell you, it sucks when it's winter. Anyways, is this person safe here? It would appear so, but I would say no. Look where this guy is strapped. He's got this harness. Okay, maybe this harness is approved to whatever area he's working on. All right. He's got a lanyard, and that looks like a lanyard that is going to expand upon the shock. So it's not going to just snag him. You need some sort of a give, like a spring-loaded action to to make the fall or the stop gradual, right? And some of the lanyards can do that, and they should be that they do that. um it's some of them are like they behave like a spring or a rubber kind of thing. They have the same action. When you fall, you don't get stopped like boom, right? You just go right. So some of the lanyards, they are folded at some point, and at the weight of the fold just gradually unfolds, and that amortizes a little bit the fall. So he's got a lanyard here, and wherever he's strapped, I don't know where he's strapped. Maybe somewhere. I hope he's strapped somewhere at this point. I hope he's not strapped here. Sometimes some people improvise their own fall arrest harnesses, and in a way that they have a strap right on their chest. Well, that's fine if you are just supporting yourself, if you're climbing a mountain or something. But if you fall while having that, the gradual stop will break your back. Right? It's just going to break you in half. Now, is he safe the way he's strapped? Most definitely not. He's strapped right to the platform. Look how far he has to go. And gravity can be really not friendly when it comes to that. When he falls, here's the length of the lanyard. He's going to go his length plus the length of the lanyard, well, the length of the lanyard, and that's he's going to come to the sudden stop. Mm, uh, well, that's how you get your spine broken in half. That's all I'm going to say about that. Right. So, but when you get the proper training, you should know by then what to do, what not to do, how to protect yourself properly. I'm just kind of giving you the little bit of awareness of that. All right. Type of skill. Okay, so here's example of a fabricated frame. What does it mean? That you don't put the whole thing together yourself from 2x4s and whatnot. You just either buy it or rent it and set it up, and it just gets put together as Lego, right? So that's called a fabricated frame. um, we need to have guardrails installed, right? And the guardrails, there are certain rules and regulations that you need guardrails. If you're working on the roof, if you're working on the scaffolds, you need guardrails. Whenever you drive by again and see people working on the roof, you see workers on the roof, you're going to see guardrails installed, and they have to be installed so the construction site could be legal. All right. So same thing with the scaffolds. You can't just have a platform and you can just fall off that. Guardrails are needed to be installed. Right. Need to be installed. Cross bracing. What's a cross bracing? It's these rails right here. This one here and that one here. All right. And they're joined right in the middle. So once you disassemble the whole scaffold, the cross braces, they get detached from the mounting points. 1, 2, 3, 4 mounting points right here, and then they just in the form of an X, they just come together just like that, and they can be transported or stored away. Right? So that's the cross braces. And of course, a few slides back, if you when you get this thing downloaded, you're going to see something that says do not climb cross braces. They are not designed for you to climb them to get to the top of the platform. Are you going to see some people climbing them? Yes, but doesn't mean you have to do it. It's dangerous. It's not designed. They're not designed for climbing. All right. Uplift pins have to be used when you put the whole thing together. So there's one piece that goes onto another, and that's how you build the whole thing. What if there's some movement? Upon some movement, those things can come apart. So when you put together, there's an opening goes right through to one of the one piece, and then the inner piece and the other piece, and then you're using the cloth to just pin them through, just so they don't come apart while being used. All right, now here's a slide and a half. All right, what does this one say? um, mm, mm, mm. Scaffolds with a height to base width, scaffolds with a height to base width ratio of more than 4:1. So there's a height, right? And here's a base width. If the ratio between this and that is more than 4:1, then the scaffold must be restrained from tipping. Remember that I was talking to you about the center of gravity? When does the object tip? If the center of gravity goes beyond the base. then you can count on it. It's not a big philosophy. It will tip. Right? So here's the rules. If the height to the base width ratio is more than 4:1, scaffold must be restrained from tipping by guying, tying, bracing, or other equivalent means. What's guying? Okay, I'm pretty sure when you drive by, I'm talking about a lot about driving by things, no, but this is how you notice things, right, that are outside. All right, see some of the communications towers, and you see some of the ropes that are holding that tower and preventing that from tipping. These are guy wires. That's what they call guy wires. This would be the braces. All right, so guying using guy wires that could be used. Tying, you can tie things to the wall if you can, or bracing, which is bracing. You see that bracing extends the size of the base, so your center of gravity is more secured within the whole structure. What else do we have? Oh, equivalent means, and I don't have a picture of equivalent means. Right. All right, mobile scaffolds. That's an example of a mobile scaffold here. Do not move while occupied unless specifically designed for such movement. Statement and a half. All right. There's a reason why that statement is there. What could that be? Never mind. Before moving, inspect for pits, holes, and obstructions on the floor. So before you're moving on the floor, inspect that it's safe to move. Make sure there's no any holes or pits or any other obstructions when you're moving it. Now, when you're pushing it, push the base. So closer to the base, closer to the bottom to prevent from tipping. Obviously, when the lower you push, the less of a chance you have for tipping over this whole structure. Right? Mobile scaffolds, while in use, while not moving, caster wheels, these are caster wheels, casters, right? Caster wheel must be locked to prevent movement of the scaffold when stationary. Right? And there are different ways of locking. Usually there are those foot brakes. You just press on the brake here and it locks it into place and makes that wheel immobile. And if you want to move it, you press the other side of that and it unlocks it. And one other thing I'm going to mention is scaffold brackets must be constructed. So here, basically what this thing here says, all right, is that in order for you to have a proper platform that you can stand on or sit on, it has to be leveled. So it has to accommodate the pitch of the roof. That's basically. If you can nail it, nail it. If you can't, you need to place ropes, and there's specific ropes, and they have to be done specific way. And of course, I'm not going to go into any of the details of that because this is not a formal training of how to use it. I'm just raising your awareness. Everybody has to go to official training that is done by the whoever people are doing the safety committee. Right. All right. And that's the last slide of this thing here. How much time do we have? We have about 10 minutes. So let's talk about some pipe bending. I always want to touch up on this on the pipe bending thing. Right? What was I talking about during the last? Oh, okay. Yeah. Remember, we have the we have ideal brand, ideal pipe benders in our school. However, also a popular brand is the Klein brand. Klein brand. Now, the ideal one and Klein brand, they're pretty similar. They behave slightly different, and some people prefer one way, some people prefer the other ones. If you notice that, here's some information. I wonder if you can see that. Here, it says 1/2 inch EMT only. Okay, see that? 1/2 inch EMT. That means that the size of this shoe here is accommodating 1/2 inch pipe diameter, inside diameter. It's a standardized. Some of the ones that we have are also 3/4 of an inch, EMT, electrical metallic tubing. And it might say the ones that say 3/4 EMT, they're going to say here on the other side, they're going to say half-inch rigid conduit, because rigid conduit is thicker. So the 1/2 inch rigid has outside diameter same as 3/4 inch EMT. Right. So when we do, because we are using 1/2 inch pipe EMT only in our class, we are going to use the ones that we have that say 1/2 inch EMT. We have most of them 1/2 inch EMT, and we got a couple of 3/4 inch hanging by the stairwells there. Right? What else does it show here? I want to point you to this sign here. You see that? Right here. It says stubs to 5 inches to arrow. Okay, stubs 5 inches to arrow. Here's the arrow right here. That's where the arrow is. And this is how we place the pipe in right here. Here. Okay. And here's my back scratcher. And we bend the pipe that way. Right? So if we make a mark on the pipe right here, sometimes we use the arrow to align with the marks that we make on the pipes. Not bending my back scratcher. What does this mean? What is a stub? A stub is a 90-degree bend. Right? Okay. Just put that thing so it doesn't fall down and make a noise. What is a stub? Let me just go back to screen sharing here. Share. All right. I keep forgetting to press the last button. You should see my whiteboard soon. There we go. All right, let me erase the whole thing. That was from the previous class. There we go. So if you have a straight pipe, that will be a straight pipe. If you take that pipe and you bend it 90 degrees, it's a stub. You just made a stub. All right. Got that? Got that. Erase. Just make that eraser here. All right. Makes it real. All right. Now, when you have a straight pipe, you make a mark wherever it is. You make a mark on that pipe with your Sharpie or what, pencil or whatnot. All right, let me just before we do that, I need to bring up the chat in case somebody wants to say something to me. I can see your chats now. All right, so you make a straight mark, or just a mark on it. And then if you put that mark and you align that with the arrow of this pipe bender, and if you make a stub, which is 90-degree bend, that information tells us that this mark is going to find itself 5 inches from this surface here. This is going to be 5 inches. Okay. So that's the information that says 5 inches to the stub right here. Different size conduits, they will have different information on that. But this one here, 5 inches. So if you want to have certain length from here to here, certain distance, because whatever you're bending the pipe to accommodate whatever the installation you're doing, and from here to here, you're going to have, let's say, 10 inches. So you're going to subtract the 5. You're going to, from this point here to whatever mark you're going to make, you're going to subtract 5 inches in order to have 10 inches here. Some of us already tried that. We made a mark 10 inches from the edge. We bent that and we ended up with this thing here 15 inches because you're adding 5 inches. So that's that thing. Okay, now as far as practicing doing the offsets, what's an offset? Well, if there is a surface and then there's something else on the surface, right? And maybe there's a box right here. All right, whatever. There's something here, and you're running a pipe, so you're going, oh, whoa, can't go further anymore. Okay, well, you gotta kind of step up. So you're going to offset, make an offset. So, in order to make offset, you have to rise it and then continue. So you have to bend it certain degree here, and you have to bend it back the same amount of degrees in order to overcome whatever the height of the offset is. So that's an offset, just as a reminder. All right. Now, on this, there's some stickers on the. Do I have some of that? No, not yet. I'm not finished with that yet. But there's stickers on the handles on the ideal pipe benders, and there are stickers on the handles of the well, for example, Klein. So let's take a look at this sticker here. This sticker shows, let me just stop sharing, see if we can take a look at this sticker. The light is not very good. Yeah. Here's a sticker. All right. Can we see that? Yes, we can. And over here, what does it say? It says 1 inch. Then it says 6 inches. And then there's some different angles, right? At 10 degrees and so on. So let's take a look at one of the, I'm just going to copy that from this sticker here. So bear with me. I'm going to share the screen again. Almost done. Share screen. This one. Share. All right. We're sharing already again. Or are we? I still see the time glass. All right. Participants chat. Good. All right. So let's take a look at this thing here. One of the rows of this sticker. It shows, let's say, well, if we want to overcome 6 inches height. Right. So what do we have? We have 6 inches. Then we have next thing, next row says distance between the bands. It says 8.5, 8.5 inches. And we have 45 degrees angle. 45 angle. And the last column says 2 1/4. All right. So here's the obstacle. Here's the height of the offset. Here's the distance between the marks, band marks. Here's the 45 degrees angle. Let me just do a little thingy here that's gonna make it look like 45 degrees angle. And the pipe is going to shrink. The pipe is going to shrink 2 1/4 of an inch. Let's see how we're going to get to that. I chose the 45 degrees angle. I should have chosen different, but let's work with 45 degrees. That's fine. All right. So here's the pipe, here's 45-degree angle, and we're continuing that. The height of the obstacle is 6 inches here. All right, 6 inches. And the degree, the angle over here is 45 degrees. And it tells us that this here, this length is going to be, the travel is going to be 8.5 inches. And the pipe is going to shrink that way 2.25 inches. If it were a straight pipe, because we're doing the offset band, it is going to this length here and this length here. For the straight pipe is going to be a little bit longer, and of course that thing is going to retract a little bit because of the bend that we're doing. How do we get there? How do we calculate the distance between the bending points? Well, remember, first we gotta find out what the multiplier is. And the multiplier is the cosecant of the angle that we are using, right? So let's say, what's the sine of 45 degrees angle? Oh, that's going to be funny. I shouldn't have chosen that angle. Oh my God, that's okay. Let's see what we're going to come up with. All right, sine, cosecant is 1 over sine. So 45 degrees, let's just go to the motions. And trigonometry, let's do sine. It is 0.707. But the 1 over sine, we have to flip that, is going to be here. It's 1.41. There you go. So the multiplier is 1.41. Let's just 1.41. Okay, so that's the multiplier. Now we use that multiplier to our advantage. In which way? This travel distance is equal to the multiplier times the height. So that number here, 1.41 or 1.414 times 6 inches times 6. That's going to give us 8.48. All right, see that? Which, so that's why we have 8.5. So that's how we got that number. All right, so we're working 45 degrees. How is it that the pipe is going to shrink? It says it's going to shrink 2.25 inches, 2.25. All right, remember the formula for that. That's one thing you just have to remember. The shrink per rise length. Right. So if we are working with inches, we're going to work with inches. If we're working in centimeters, we're going to specify that in centimeters. But let's work with inches right now. Right? Shrink per rise. So it's going to be shrink per inch, per every inch of rise. And this is our rise right here. Right here. Equals sine of the angle, which is that one here, over 1 plus cosine of that same angle. All right, so what do we have? Remember what we had for the sine of 45 degrees? All right, let's just do it again. Is it 707? Let's verify it. 45 degrees sine 0.707. right? So we put that in here. 0.707 divided by cosine of the 45 degrees angle, and that's going to be funny. Look, 45 trigonometry cosine. Oh, look, 0.707. All right. All right, but we have to add 1 to it. So we're going to add 1 to this. Plus 1 equals 1.707. Let's put that in the memory. Memory plus here. These are going to light up. All right, so we have that in memory. Divided by 1.707. What are we going to get? So we still have that in the memory. Okay, so 0.707. 0.707 divided by the memory recall here equals, what do we have? Where's our, 0.45, 0.45. Pencil, 0.45. Okay, now that is per every inch of rise. So how much is the whole pipe is going to shrink? We're going to have to multiply this here, this number, by this here number to find out how much this length is going to be. Right? So 0.45 times 6. Kaboom, kaboom. We already have that number. Times 6 equals 2.7. And this one here says that we're going to shrink that pipe 2.25. So did we do something wrong? Or did I write something wrong? 6 inches, 45 inches, still says 2.25. But according to our calculations, unless we missed something, it's a little bit slightly different. It's almost 3, right? So it would be closer if it said 2.5, right? So always verify things. What we can do is we can look at this sticker on the handle, right? And we can verify that with the reality. What does the, just for kicks, okay? I'm just gonna go Google. Bender guide ideal. Let's look at the ideal sticker. Yeah, that's the sticker. Let's see what the table says for that on the ideal pipe bender. Offset, offset, offset. Here's the offset. Here is the table. So we're talking about 6 inches, about, and 45. So here's 6 inches. Here's 45, and it shows 8.5 between the 2 points, and pipe is going to shrink 2.25 inch. So either we did some wrong with the calculations, or there's some other reason. But you know what? Next time we are in the lab, let's put that to a test, and we're going to solve the mystery. All right, it's 2 o'clock. I know I held you. I should let you go 10 minutes ago, but we were just solving some important mystery here. Okay. Well, guys, it's Friday. Have a great weekend, and remember, there's going to be a quiz next week, and I'll see you when I see you. Have a great and safe weekend. Okay, bye, guys. Okay, how do I stop this? Yeah. And